Hi, this is Ms. Cho with how to factor quadratic equations and expressions using the area model. This is a visual method that works for any A. Let's take a look at some examples. You may recall that the area model is a way to multiply factors with multiple parts. For example, if we had x plus 7 and x minus 2, this is a way to stay organized. And the entire premise is that the area of the whole rectangle is the same as the sum of the area of its parts. So the area of the mini rectangle on the top left is length of x times width x, which is x squared. On the top right, it's a length of x times a width of positive 7, which gives us positive 7x. On the bottom left, negative 2 times x is negative 2x, and on the bottom right, negative 2 times 7 is a negative 14. From there, we can combine like terms, which gives us x squared plus 5x minus 14. When we factor using the area model, we are doing the exact opposite. Here we are starting with 3x squared plus 2, and we know that our diagonal like terms add up to minus 5x. What we don't know is the length and the width of the rectangle that gave us this area. To find that, we find the factors of A and find the factors of C. So what did we multiply to get 3x squared? This was x times 3x. What did we multiply to get 2? It was a 1 times 2. From there, we try different combinations. I'm going to try an x here and a 3x here and a 1 here and a 2 here. It doesn't matter which order you try them in, you just keep going until you find the right answer. Here, because this is a positive 2, we know that this has to be a negative 1 times a negative 2. And so when we multiply this out, x times negative 1 is negative x, negative 2 times 3x is negative 6x, and our sum of negative 6x and negative x is negative 7x, which does not match. So now I will try the other combinations, keeping my x and my 3x, but just switching the 1 and the 2. And again, because they multiply to a positive number, I know that they have to be a negative and a negative. Now when I multiply x times negative 2 is negative 2x, a negative 1 times a 3x is negative 3x, and this does add up to negative 5x, which checks. So now I can rewrite my factors. It's 3x minus 2 times x minus 1. And if you're not sure whether this is correct, you can multiply it out algebraically. 3 times x is 3x squared. 3x times negative 1 is minus 3x. Negative 2 times x is minus 2x. Negative 2 times negative 1 is positive 2. And we combine our like terms to get negative 5x, and this matches the expression that we started with. Let's try a second example. Here we have y is equal to 4x squared minus 2x minus 42. One thing that I forgot to mention before is that if you have a common factor for your entire expression, you want to factor that out first. That will reduce the number of combinations you have to try. I notice that all my terms are even, so I can factor out a 2. When I divide each term by 2, I am left with 2x squared minus x minus 21. So first, take the GCF out. Second, I want to find the factors of A and C. My new A is 2, and my new C is negative 21. So what did I multiply to get 2x squared? Well, this is x times 2x. And then what did I multiply to get negative 21? Is 3 and 7. Then I can try different combinations, knowing that I should end up with a 2x squared and a minus 21. I'm going to try putting the x here and the 2x here, the 3 here, and the 7 here. I know that because this is a negative 21, one of my constants is going to be negative, but I don't know which one yet, so I'm going to hold off on that for now. When I multiply x times 3, I have 3x, and then when I multiply 7 times 2x, I have 14x. I can't add or subtract 3 and 14x to get negative 1x, so this is not the right combination. I'm going to try the other one. The other combination puts a 7 here and a 3 here. And when I multiply x times 7, I get 7x, and then 2x times 3 is 6x. There is a combination of 6x and 7x that gives me a negative 1x, and I have that by taking a negative 7x and a positive 6x. Therefore, My negative comes up here with my 7, and my positive is here with my 3, and my factors are 2x minus 7 times x plus 3. To summarize, when you're factoring using the area model, first you factor out the GCF if there is one. Then you draw a box, you fill in what you know, and you list factors for A and your factors for C. Then you're going to try out different combinations until you find one where your diagonal adds up to your B. And you choose your appropriate sign and you rewrite as a product of factors. If you're not sure if you did this correctly, you can always check 2 ways. One is algebraically, where you can multiply out your terms and you see if it comes out to the same expression that you started with. And the second is graph. So you can graph your factored form and you can graph your standard form and to see if the graphs that you get are the same. If they match, then you've done it right.